Hello everyone, my name is Surendra Ambati. This is prerequisite video for threading and multiprocessing. In this video, we'll going to discuss a few of technical terms. Those are like what is process, what is processor, what is program, what is CPU core, what are input output bound and CPU bound task, and what is concurrent, what is parallel thread, etc. Let me write it down on my screen. It's a prerequisite video. Let me write topics. Process, program, process, CPU core, input output bound, and CPU bound task, concurrent, parallel execution, what is threading, and how a program execute by processor or CPU. We'll look into all these technical terms. First, we'll see what is processor. Processor is also called as a central processing unit, and it is like a brain of our computer, and it deals or it is a part does all thinking, like running program, performing calculations, and handling task by executing instructions from our code or application. And processor contains everything that need to process instructions like ALU, CU, register, cache, etc. And I'll explain all these topics inside the CPU in a while. But first, we'll write a short definition of a processor on a screen. It is also called CPU, and it performs run program, perform calculations, and handling task by executing instructions. Okay, that is what processor is. And we'll see what is program. Program is a set of instructions that our computer can execute. In other terms, it is a collection of code and data that perform a specific task. So a program can be also written in various programming languages such as Python, C++, Java, etc. And majorly this program can be executed by operating system, which initially this program can be loaded into the memory and it runs. We will see the process how the program execute by processor at the end of the video. So in short, program is a set of instructions that computer can execute. Let me write that also. Is a set of instructions that a computer can execute. That is what program is. Now we'll see the process. Processor is a different and process is the different. Process is instance of a program that is being executed by processor or CPU. That is what the process is. uh, it has its own memory address space and also come uh, some common resources for the process. Okay. Every process requires, you know, code segment, data segment, heap segment, stack segment, and register, etc. These are all needed to execute it, or to execute a program, or process need all these components or segments to run a program. And these are all things managed by the operating system, and it can runs independently. In Python we can use the multiprocessing module, and we can create multiple processes to run task in parallel by bypassing the GIL, or global interpreter lock. Okay. And in short I can say process is a just instance of a program that being executed by processor. A process is an instance of a program that is being executed by CPU or processor. So that is the major difference between the processor and process. Okay. If any program runs by processor, then that is a process. I hope you understand the difference or the meaning about the process. Now let's see what is CPU cores. These are all topics are needed to understand, better understand on threading or multiprocessing. So that is the reason I just want to explain these topics first. So let's see what is a CPU core. So a core is a processing unit inside our, you know, uh, processor. Each core or each processor may have multiple cores, and each core can run its own thread, or by using the hyper threading also it can, you know, run the multiple threads. In our modern processors we can have a multiple cores that I mentioned before, right? Even processor have the multiple cores. So multiple cores, that is why we can say that our system having 4 core or 8 core, that is what it means, our processor having the multiple cores. So if I want to give you one layman example, cores are like workers in a factory. So each core can work independently or together. So finally core is a part of processor, and it is not a whole chip. In short, let me write CPU core, or a core is one processing unit inside a processor. I'll explain this shortly. What is the processing unit and what are all components it has? Everything I'll walk you through with diagram. Now let's see what is input and output and CPU bound task. Input and output bound and CPU bound task. Input output bound, that spend most of the time, like, you know, waiting for external operation to finish. If I want to give an or quote an example, downloading files. So we wait to reach to the certain network, or reading the databases, or web scraping. These are all examples that comes under the input output bound task. uh, so if I want to give a layman example, that if we want to order a coffee where we spend 95% of the time for waiting and in a line, and only 5% of the time that we spend for paying and grabbing the drink. So this is the example that I can say for input and output bound task. The reason I'm explaining the input output bound task, that this is the core philosophy that where uh, threading and multiprocessing differentiate. Threading majorly uses input and output bound task. So that is the reason you should know uh, the reason difference between input and output bound and CPU bound task. Let me write the definition of input and output bound task. uh, Input and output bound task that spend time waiting for external operation to finish. Okay, so I already gave you the example. Let me write it on my screen. Downloading files and reading databases and web scraping. These are all examples for the input and output bound task. And now let's see what is a CPU bound task. CPU bound tasks are like spend most of the time for crunching numbers using the CPU. If I want to give an example, like calculating the prime numbers, or processing images, or training machine learning models, or video rendering, these are all the best examples for the CPU bound task. And another example, that suppose a math professor solving hundred and thousands of complex equations, they can spend they cannot speed up or spend time for by waiting to complete those complex equations. Then they need more and more professors. It's like CPU course, adding the more and more course to that. So that is the analogy that I can give for CPU bound task. Let me write the CPU bound task that spend most time crunching numbers using the CPU. Examples: calculating prime number, processing image, etc. So these are the major two differences between the input and output bound tasks, and this is really important to understand these two differences. So for waiting related task, or you know downloading file or readable database, this type of task that we can handle using the threading. And CPU bound task, like calculating the prime numbers or processing images, these are all tasks that can be handled by multiprocessing module. So that is the difference between these two. uh, that is the reason that we have a two different modules: threading and multiprocessing. And also let me give you a few of the differences, key differences: input output bound and CPU bound. In input output bound, the bottleneck is waiting for data, and the CPU, the bottleneck is calculation speed. And the modules that we use to handle the input output bound task are like threading, asynco, concurrent dot futures. These are all the modules that we use to handle the input output bound task. And for CPU bound task that we use multiprocessing module. And here this is a bottleneck. Please forgive me, my writing is not that good. And these are the modules that we use for the both. Okay. And also, you know, CPU usage in input output bound task, it is a low, and here 100% core utilization. So these are the main differences between these two uh, tasks. Okay, that is all about input and output CPU bound task. Now let's see what is concurrent. So concurrency is about dealing with a lot of things at once. It is like, if I want to give an example, that student flipping between the tasks, like reading a textbook at the same time checking Instagram or watching YouTube videos. Okay, they are switching quickly uh, to make progress on each. That is what they do, right? But if you see, at any point of time only one task is happening. Okay, it feels like multitasking, but it's really just fast switching from one task to the another task. That is what happening in concurrency. Okay, that is why I mentioned concurrency is all about dealing with a lot of things at once. Now we'll see what is parallelism. Parallelism is about doing lot of things at once. Parallelism is about doing lots of things at once. Okay, this is more about execution involving multiple CPU to handle different tasks simultaneously. If I want to give an example, that four students working together, each one tackling different subject at same time, like one reading a math and another one reading history and so on. So there is a no switching, or you know it's just simultaneous work. And that is what all about the parallelism. So parallelism here that we need to understand, it's multiple people do the separate task at once. That is what the parallelism is. And whereas concurrency is one person handling the multiple tasks. That is the main difference. In concurrency, one person handling multiple tasks. Whereas parallelism, multiple people doing separate or individual task at once. So that is the difference between parallelism and concurrent. And now we'll see what is thread. Okay, thread is a lightweight process that shares the same memory space as the main program. In other words, threads are like smaller unit of work with a single process. Okay, and each thread shares. I already mentioned each thread shares like code segment, data segment, heap, and stack spaces. But stack space shares separately by each thread, and CPU do this job of threading individually, and these threads are majorly used for the tasks that related to the input output bound task, or which requires the frequent context switching. So in any of the cases that we can use this threading concept. Okay, let me write the definition in short. A thread is a lightweight process that shares same memory space as the main program. Here the key point we need to remember: process, lightweight process. That is the key point of a thread. So in Python, threading models, allows us to create a multiple threads to run tasks concurrently, but we know that it is limited by the GIL. But still, we can create multiple threads using the threading module. That is all about threading. Sorry, thread. Now we'll see how a program executes in a memory. For that, I already drew a diagram here. If you see, this is the behind scenes that happen uh, once we execute the program. So generally we let me yeah generally we use the input devices to insert or write our program, and those input devices like keyboard or any other input devices that we can use it. And once we write that program and we start the executing it, then what happens that instructions program is nothing but the list of instructions, right? Though those all list of instructions will go to the RAM. Okay, random access memory, and it stores in a different way. I mean, that program can be segmented in a different way. One is the code segment, data segment, heap segment, and stack segment. Okay, uh, code segment, majorly this one majorly contains actual instructions that CPU executes, and you know it cannot modify during the execution. Code segment cannot be modified during the execution. And data segment is like it's contain the global variables and static variables from our program that used by the processor to execute a program. And heap and stack segments are like those both are data structures, but they have a different characteristics. Heap is a data structure that stores data in a dynamic manner, whereas a stack is a data structure as well, but that stores the data in LIFO manner, which is last in and first out manner. Okay, heap generally used to store global variables and objects in a program, whereas stack stack segment used to store function calls and local variables in a program. That is the difference between the heap and stack segments. And once all these instruction load into the certain segments, and it will uh, process via registers and memory unit in CPU. This is called a CPU. This is called CPU. In this CPU we have a majorly three components. One is a ALU, which is arithmetic logical unit, and another one is CU, which is a control unit. And in this memory unit we have two parts. One is register and second one is cache. Okay. uh, CU generally controls the flow of data within the CPU. Once they receive the data via memory unit, and it directs the operation of processor or CPU by telling to the ALU or memory. Okay, or otherwise, other input output devices what to do. It generally directs those operations. That is what the control units do. And coming to ALU, it is a part of the CPU that performs arithmetic operations like addition, subtraction, and logical operations like and, or, not. These are all that performed by arithmetical logical unit. And you know the role of ALU is like in executing all mathematical and comparison based computation it performs. And control unit role is like act as a traffic controller of the CPU, that fetching the instructions from memory, decoding them, and coordinating their execution. These are all that performed by control unit. And coming to the registers, registers are like small and high speed storage units inside the CPU itself. And it generally holds temporary data, instructions, or addresses that are useful for uh, executing program. Okay. And we have a different type of registers. Those are like program counter, accumulator, and instruction register. These are all the different type of registers that we have. And coming to the cache, it's like in a small memory, but it is a high speed memory located inside the CPU itself, and that stores the frequently accessed data and instructions. And even cache also have a different levels. One is L1 cache, L2 cache, L3 cache. This name itself, like L1 is the smallest one and L2 is the larger and L3 is even larger. But here the main thing, like these are all located inside the CPU, but memory wise also it is a limited memory. The role of the cache is like you know uh, reduce the latency by avoiding the frequent access to slower RAM. That is what the cache generally does. Okay. And once all the process happened, and again it pushed back the result to the RAM, and the RAM provided those output to the devices, either to monitor or printer, speaker. So this is how the entire the process happens behind the scenes once we execute a program. I hope I'm clear with all these topics. uh, these are all really really important to get better understanding about these two modules. I If you have any doubts, then I request you to watch the video again. So that's it about in this video. We'll meet you in another video. Thank you.